Today we're going to talk about the property of exponents, specifically multiplying and dividing powers. This is going to be in pages 4 and 5 in your packet. So our learning goal today is I can rewrite expressions involving rational exponents using the properties of exponents. So some important vocabulary, some of it's a review. So a monomial is a number, a variable, or a product of a number and one or more variables. So for example, 34xy, 7a squared b. So we've got 5 squared there. 5 squared, that entire thing is the power. The base is 5 and the exponent is 2. So we're going to look at first the product of powers. So algebraically, what that means is when you have a to the m power times a to the nth power equals a to the m plus nth power. So if you multiply two numbers with the same base, you're going to add the exponents. So that's important, is that we have the same base and then you add the exponents. And I'll show you, for example, why that is. So let's take a look at our first example. So if we ask you to simplify the exponents as compared to evaluate, those are two different things. Evaluate means we want the actual value. I want to know what 5 squared times 5 to the 6th is. Sometimes we just want you to simplify it. So in this case, we want 5 squared. So we know that that means 5 times 5. And then we're going to multiply that by 5 to the 6th. So now we want 5 to the 6th. We want 5 6 times. 1, 2, 3, 4, 5, 6. So we're multiplying all that together. So I can go ahead and get rid of those parentheses. So I end up with 5 times 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 5. So that becomes 5 to the, and if I count my 5s, we had 1, 2, 3, 4, 5, 6, 7, 8. So that becomes 5 to the 8th power. If you go back and look at your exponents, again, we've got the same base of 5 to the second and to the 6th. Well, 2 plus 6 is 8. What I would like you to do is I would like you to write this step out to begin with. Reason being is because you're going to be less likely to make a mistake. Let's take a look at our next one. So we've got y to the 4th times y to the 3rd times y. So I'm going to write out y to the 4th, so that's y times y times y times y. And then we've got times y to the 3rd. Make sure that's a times. So y times y times y. And then times y. Don't forget about that y on the end. So I'm just going to rewrite that without the parentheses. So now I have y times 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 y. Again, same base. And then we're going to count how many we had. We had 1, 2, 3, 4, 5, 6, 7, 8. So that's a y there. Again, go back and look at your exponents. We had a 4. We had a 3. If you don't see an exponent there, it's a 1. So 4 plus 3 plus 1 is 8. In this next one, what I would do is I would group my coefficients together. So it's going to be 7 times 6, and then group those exponents together, times y to the 5th times y. Now, do not get this mixed up. We are not adding those together, because if there was a plus sign between that, you wouldn't be able to combine 7y to the 5th plus 6y. But when you're multiplying, it's a different story. That's a different rule. So we've got 7 times 6, we know is 42. And then we've got y to the 5th, so 1, 2, 3, 4, 5 times y. So our final answer would be 42 y to the, let's count them, 1, 2, 3, 4, 5, 6. multiply my coefficients. We've got -3 times 5. I'll group my, okay, so now we've got x squared times x times y to the 7th times y to the 6th. The property that allows us to do that is the commutative property. So we get -15 x times x times x times y, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So we get -15 x to the 3rd, y to the 13th. Now if we count, 1, 2, 3, well then that adds up to 13. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Go back and look at our exponents. So our x's, we had a 2 plus 1, which is 3, and then 7 plus 6, which is 13. So that is your product of powers. We also have a quotient of powers. So quotient means division. So if you're dividing two numbers with the same base, again, there's that key there, same base, you're going to subtract the exponents. Again, I'm going to show you why this works by writing it out. So up at the top, you've got y to the 6. So I need 6 y's. So again, going back to the work that we did yesterday, just like if we had 2 to the 6, that means 2 times 2 times 2 times 2 times 2 times 2. Same thing with our y's. So I've got 6 y's in my numerator and 1 y in the denominator. And then once you've got that, cross off what you have in common in the numerator and denominator. And what we're left with is 5 y's in the numerator. So your answer would be y to the 5th. If we go back and look, 6 minus 1 is 5. Let's take a look at the second one. We've got the same base as 6. So we've got 6 to the 13th. So I'm going to write out 6 13 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to double check that. 1, 2, 3, 4, 5, 6, 10, 11, 12, 13. Perfect. And then 6 squared. So 6 times 6. Cross off. I've got a 6 in my numerator, 6 in the denominator, 6 in the numerator, 6 in the denominator. So we're left with, let's go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 6's in our numerator. So it's going to be 6 to the 11th power. We're going to talk about negative exponents in a later video. But what you notice is, where did our answer ended up? It always ends up where your larger exponent is. So for example, going back in the first one, 6 is greater than 1. 6 was the numerator. Our final answer is in the numerator. And number 2, where's your greater exponent? It's in the numerator. So our final answer is going to be in the numerator. You're going to see some examples later where you're going to need to, it'll be in the denominator, okay? So let's take a look at that next one. We've got 10 over 15, and 10, a to the 7th, b to the 9th, over 15, a to the 5th, b to the 9th. So let's go ahead and start by writing this out here. So we've got 10, write that all out. We got 7 a's, so 1, 2, 3, 4, 5, 6, 7. 15, we've got 5 a's in the bottom. 1, 2, 3, 4, 5. And then we've got 9 b's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll cross off our a's. So 1, So we're left with 2 a's. Uh-oh, all the b's canceled. Guess what? We're going to learn about that tomorrow. So when you've got b to the 9th, b to the 9th, that becomes b to the 0. Any number raised to the 0 power is 1. So we're left with 10 over 15. That a was in our numerator, so it's going to stay in the numerator. So it's going to be a squared. Again, look, 7 minus 5 is 2. The one last thing we have to do there is we do need to simplify that 10 over 15. So I know that I can divide 10 by 5 and 15 by 5. So our final answer is here, 2a squared over 3.